Hello friends, welcome to the third part of our Ultimate Architectural Visualization course. I am Oz. In this section, we will create our essential smart glass material used in all of our projects. To quickly proceed with our project at the end of the day and avoid re-entering the blueprint system, we will manage to process through material instances with the parameters we create. Let's start without wasting any time. You can begin by opening the interior level in the ArchViz project folder. Then create a subfolder named Smart Materials in the material folder we created in the UAV course folder. Let's create a new material blueprint in this folder and name it Glass Basic. In the previous lesson, we understood the basic logic of the material system, but that was just the beginning. There are tons of settings to adapt to different material types in the material system. Today, we will work on translucency settings for our glass material. Let's start adjusting the details panel on the left by clicking on the materials node. The opacity node must be activated for our glass material. Otherwise, our material will not allow light to pass through. Below the details panel, change the blend mode to translucent and the shading model to thin translucent to activate our opacity entry. Also, under the translucency tab, change the lighting mode to surface forward shading. Along with these, there is an entry in our main material node that is not specified but necessary, named thin translucent material. Right-click in an empty area to add our entry and connect our white color to the parameter. Next is to create parameters to determine the color of our glass. While holding down the 3 key, we can summon two RGB colors to the blueprint by left-clicking in an empty area. Right-click on the colors to convert them into parameters and name them inner color and outer color. You can update these colors as the desired default colors for your material. For this purpose, I will update them to black and gray. We will achieve the transition of our colors with the lerp command. However, we need a texture to smooth the transition, and instead of looking for the texture outside, we will use Unreal's Fresnel command. Right-click and search for Fresnel to find the node. Fresnel is a term used to define how light you see reflects at different intensities depending on the angle you look at it. For example, if you stand above a pool and look directly at it, you won't see much reflection in the water. However, as you start moving your head to make the water in the pool parallel to your eye level, you will notice increasing reflections. We will control this setting by connecting a single channel parameter to the exponent in input. Let's name this parameter Fresnel setting. If we enable the preview feature by right-clicking on Fresnel, we will have a better chance to examine it. As we change our parameter, we will observe the decrease in our white color. I decided that values between 0 and 20 would be suitable, so I changed the slider max value of our parameter to 20. This way, when we play with our parameter on the material instance, our maximum value will be 20, making it easier to control. Now, we can connect our lerp command to base color. We see our color as pitch black, but do not worry. It looks like this because we haven't made our adjustments yet. We can select the nodes we used to create our base color and group them by pressing C. Let's name our group as color, and for parameters we created, after selecting them, under the details panel, change group name none to color. This way, our parameters will appear under a group, preventing complexity when making changes. Now, it is time to adjust another simple data. You can directly turn metallic, specular, and roughness data into parameters by right-clicking and selecting Promote to Parameter. You can set default values for metallic as 0, specular as 0.8, and roughness as 0.05. Let's group these parameters by selecting them and pressing C, and name it to General. Also, don't forget to change the parameters group under the Details panel. Next is the opacity input. We will be using the Fresnel node here again. Let's continue connecting the lerp command to our opacity input. This time, unlike what we did with base color, we will connect single channel parameters instead of three channels. Let's change the names of these two parameters to inner opacity and outer opacity. You can set default values to inner opacity as 0.5 and outer opacity as 0.8. Now, let's work on the Fresnel node again. We will apply the same process as we did with the base color. You can copy it from above if you wish. Let's group the nodes we used for opacity by pressing C. Then let's change the groups of our parameters to opacity. To keep your workspace organized, you can create stops in connections by left-clicking where you want. This doesn't affect performance, it just helps keep your space more organized. Now, it is time to deal with the normal map and how we will set it. We will use the normal map to give shape of our glass. By utilizing the light refracting property of our glass, we can achieve shaped glass in ultra quality. I found three normal maps that you can use in your projects. You can add these textures by dragging and dropping them into the content browser. Now we need a parameter to connect these textures. Right-click, find the texture sample node, add it to the blueprint, and drag and drop any of them while the texture sample is selected. We need a parameter to adjust the repetition frequency of our texture. Let's create it by calling the multiply and text coordinate nodes and call this parameter UV coordinate. We will control this with a single channel parameter. Don't forget to change texture sample as parameter too. Now, let's create a parameter to adjust the sharpness of our normal map. We will create a single channel parameter and obtain it by multiplying the red and green channel data. Let's connect the subtracted connections from the red and green channels to the multiply node. Then, connect the normal strength to the other inputs. Now, we will create two-channeled color by using the append command. Then, we combine our blue channel with the two-channeled color. We connect this texture to our normal input. When connected, we will visualize our material. As you can see, since we haven't yet given our glass the ability to refract light, only shadows are forming. Now, let's move on to the IOR settings. IOR stands for Index of Refraction. Every transparent material refracts light to a certain level. You can easily access these values on the internet by searching for IOR values. We will perform these settings on our main material node. With the Material Attributes node selected, let's find the Refraction tab under the Details panel. You will see that the refraction method is not set yet. Change this setting to Index of Refraction, activating the Refraction Index option. Create a parameter for this setting as well. You can assign a value between 1.3 and 1.5 as the default value for this parameter. Since the refraction value for glass is between 1 and 2, I prefer to set the slider max value to 2. Finally, let's group our normal parameters. Also, let's include our IOR parameter in the general group. Now it is time to weave the material in the scene. First, create copies of existing objects and light sources in our scene by holding down the Alt key. There are small adjustments we need to make on the post-process volume to view our material in maximum quality. Select the post-process box, find Lumen under Details, and edit the settings under Lumen Reflections as shown on the screen. These settings will maximize the reflection quality. After completing the setting, you can now drag and drop our material onto our object to view it. Since we dragged our main material, we cannot easily view the parameters. For this, let's create a material instance. Double-click to open it, and see what we can achieve by playing with the parameters. There's a part that I forgot to group our opacity parameters. I will quickly add their groups to my main material. Now, after making sure to drag and drop the material instance, you can see what you can achieve by adjusting our parameters. Can you see how well our Fresnel settings work together with our normal map? Unfortunately, this setting doesn't work when using ray tracing only reflections. I am sure they will provide a solution for this in the future. You can get rid of the shapes in the glass by setting our normal strength to 0. Or if you want to change the shape of the glass, you can activate the normal map box and drag and drop other normal maps here. With this material we created, I don't think we will need additional settings for glass in the future. Our class about creating custom-made glass material was like this. If you have any questions, feel free to reach out to me on the Discord server. I wish you all happy and healthy days.